Assalamu alaikum dear students. Our today's topic is Motion and Time Part 9 Class 7th. Yesterday we were reading about distance time graphs, and in that I have shown you how a distance time graph is drawn, how it is drawn. Say for example, I'm repeating it once again. Say for example, a table is given for the motion of a car, and car is moving with such and such with this time. At 0 it was at rest, and after 2 minutes it covered a distance of 10 kilometers. Similarly, after 4 it covered 20, and 6 it covered 30, and after a lapse of after completion of 12 minutes it covered a distance of 60 kilometers. Now we have to draw this on a graph. I have shown you this is the type of graph which is drawn. This is the x-axis, this is the x-axis, and this is the y-axis. On y-axis we show the distance. And on x-axis we show the time. The time is in minutes and the distance is in kilometers. You say after 2 minutes it covered a distance of 10. After 2 minutes it covered a distance of 10 kilometers. After 4 minutes it covered a distance of 20 kilometers, and after 6 it covered a distance of 30 kilometers. Now what we can calculate from this, or see from these graphs, we can calculate the distance traveled at a specific interval of time. Distance traveled at a specific intervals of time. That means if I'll say at the 12th minute, what was the distance covered by the car? When you will join these 2 points, you will see that the distance covered at the 12th minute was 60 kilometers. And the distance traveled at a particular instance of time. At a particular instance of time, we can also calculate the distance traveled at a particular instance of time. Say for example, we take 2 corresponding points. That's between 8th and 10th minute. What was the distance covered by the car? What distance was covered by the car between 8th and 10th minute? So this shaded area, we can say at 8th minute the distance traveled by the car at 8th minute, at 8th minute distance covered was the distance covered was 40 kilometers. Similarly, at 10th minute distance covered was at 10th minute. At the 10th minute the distance covered was 50 kilometers. The distance covered was 50 kilometers. Now the distance covered between these 2 points, distance covered between 10th and 8th minute, it is 50 minutes for just 10 kilometers. So we can also see that at this point of time the distance covered was 10 kilometers. Similarly you can also see the speed of the car at the particular point. Say for example, at 12th minute, what was the speed of the car? As you all know, that speed is equal distance traveled by time taken. Speed is distance traveled by time taken. Now, as you know, I am talking of the 12th minute. Well, time is given as 12 minutes. And at 12th minute, what was the distance covered by that car? The distance covered at 12th minute was 60 kilometers. The distance traveled was 60 kilometers. Now the speed is distance by time taken. Now you can 15 by 3 kilometers per minute. It's 15 by 3 kilometers per minute. Or you can simplify it more. That's 5 kilometers per minute. So the speed of the car at 12th minute was 5 kilometers per minute. It was 5 kilometers per minute. So you can also calculate speed from this graph. Now I'm showing you some different graphs so that you can see the difference in the various types of graphs. Say for example, this type of graph is given. This type of graph is given. This is a graph. This is the origin. X-axis is x-axis. This is y-axis. Origin 0. Say for example it's 2, 4, 6, 8, 10, 12. Similarly from this distance 10 kilometers, 20, 30, 40 and 50. Now these two lines are just like this. Now can you say from these two lines, this is car A and car B, which car is moving faster? Which car is moving at a faster speed? Which car among these two is moving at a faster speed? When we join these two, look at this. The car A. This is, I have already told you about slope. The more the steep, the more the steepness, the more the slope. The more the steepness, this is more steeper than this. So this S1 slope 1 and S2 slope 2. S1 is greater than S2. That this slope 1 is greater than S2 because it's more steeper than this. It's more steeper than this. Now what happens? Now when you look at these two lines, you can see in case of car B, the car B after completion of 2 minutes, I'm talking of car B, after completion of 2 minutes, it has covered a distance of 10 kilometers. And after completion of 4 minutes, it has covered a distance of, say for example, 20 kilometers. Now if we look at 6 minutes, it has covered a distance of 30 kilometers. So it's a uniform speed. Now if we look at the car A, if we look at the car A, you can see that the car A has covered 10 kilometers in 1 minute. And it has covered in 2 minutes, it has covered 20 kilometers. Similarly, after completion of 3 minutes, it has covered a distance of 30 kilometers. That means the distance is the same, The distance covered is the same, but this car A is taking less time in completing the same distance. The car B has completed 10 kilometers in 2 minutes, but the car A has covered 10 kilometers in 1 minute. That means the car A is moving at a faster speed. Speed of car A is more. Speed of car A is more. So the steeper the line, the faster is its speed. The faster is its speed. From this you can predict the speed of the car. Now this was a case 1. Now I'm talking of case 2. Now we'll talk of case 2. Say for example, this type of graph has been given. Say this origin 0, 1, 2, 3, 4. 1, 2, 3, 4. This is distance. Here is distance. It's time. Distance, time. Now this type of graph is given. Can you say from this graph which type of motion is this? Which type of motion is this? Look at the graph very carefully. You can say after the lapse of time, after 1 minute or 2 minutes, 3 minutes, 4 minutes, the car hasn't moved any distance. It was at 3. It's still at 3. It's still at 3. It has not moved to 4 kilometers. It has not covered any distance. It's still at the very position. After lapse of time, it's still at the very position where it was at the time of origin. At the origin, it's still there. That means this body is at rest. This body is at rest. Body is rest. It's not moving at all. With the time, the body is at rest. It's not moving at all. Now the third case, case 3. Say for example, this type of graph is given. Origin 1, 2, 3, 4. 1, 2, 3, 4. Distance, time. Say this type of graph is given. So you can say that initially the body was not moving, it was at rest. Initially the object was at rest. Initially the object was at rest. Initially the object was just, after that it started to move. You can say that it's moving. The body is moving uniformly. Body is moving ununiform motion. And now this type of case 3, case 4, this type of graph is given. This is, I have already told you, this is which type of motion? 1, 2, 3. Distance, time. This is, and then straight line comes. This is a uniform motion. Uniform motion. This is also uniform. This is also uniform motion, but initially it was at rest. Initially it was at rest. After that it starts to move. The straight line says it's a uniform motion. Straight line is a uniform motion. But initially it was at rest. Now it was moving from the start. It's also uniform motion. Now the case 5 is case 5. This is like this. If this type of graph is given, that's 0, 1, 2, 3, 4. 0, 1, 3, 4. At this distance, at this time, you can say that it's not covering the equal distance in equal intervals of is not covering in equal distance of time. So this type of line shows that it's not a uniform motion. It's not a uniform motion. So these are the 5 types of cases we can come across during this lesson. Though it is now we have concluded this chapter. Inshallah, tomorrow we'll be taking up a new lesson.